Hello everybody, this is 11.2, the quadratic formula. Here's what the notes look like, and print them out and follow along. I'm just going to talk to you a little bit about why we need the quadratic formula. So for example, if you remember 2 units ago, we solved degree 2 equations by factoring, okay? So these are called degree 2 because they have a squared in them. They're otherwise known as quadratic equations. So when we went to solve, we were looking for factors of -7, and the inners and outers have to combine to give you -6. So it would look something like this. And then you would set the individual factors equal to 0 and solve for x. So you get 7 and -1 for your solutions. Oh, there it is. Okay. So degree 2 equations, we solve them by factoring. And this is going to be a lot of your life when you get into Math 180. Okay. But sometimes when you look at equations, you cannot solve them by factoring. So for example, if you look at this thing, there's no factors of -5, and the inners and the outers will combine to give you -1. So just think about what the factors of -5 are. 5 and 1, and there's no way you can combine the inners and the outers to get -1x. So this is actually not factorable, but you can still solve it. And let's just go back and look real quick at this equation on the calculator. So if you look at that equation on the calculator, and if I hit graph, you'll notice there are solutions. There's one right there, and there's one right there. But you cannot find those solutions by factoring. Okay, so we have other methods for finding the solutions, and the method that we're talking about today is called the quadratic formula. So when a degree 2 equation is not factorable, you can use the quadratic formula to find the solutions. So here's the quadratic formula. You're going to have to memorize this. Okay, A, B, and C are coefficients from the quadratic equation. So if you look here, A is the coefficient of the squared term, B is the coefficient of the plane x term, and C is the constant. So for example, let me give you a more complicated one. If I had something like this, A would be 3, B would be -1, and C would be 2. So A is the coefficient of the square term, B is the coefficient of the plane x term, and C is the constant. Okay, and that's where you pull the numbers from to go into this formula. So look at the helpful hints, and I would read through these thoroughly. Okay, so now we're going to go through and use the quadratic formula to solve. Okay, and the reason why we're saving this for the very end is because look at that radical in there. So you need to know how to simplify radicals and everything in order to deal with that. So we've just gone through that. So the first step is you always have to have one side equal to 0. So it's the same as it was when we were factoring. One side equal to 0. So move over the 4. Okay, and now decide, you're going to subtract 4 from both sides to get that over. And now decide what A, B, and C are. A is 3, B is -11, C is -4. Okay, so now your quadratic formula, x equals, and it's x equals because you're finding the solutions. You're going to have to memorize this, you guys. Okay, so now substitute into the formula. So it says up in the notes that how this is read is the opposite of b, or it can be negative b. But regardless, when you go to substitute that number in there, it looks like this. So it's going to end up being 11. That's why people say that can be the opposite of b. So it's the opposite of negative 11, which is 11. Plus or minus the square root of, notice I'm putting this in parentheses. Remember, because when you do this in the calculator, the parentheses are really important. B squared minus 4 times 3 times negative 4. All over, so big long fraction bar, 2a, so 2 times 3. Okay, that's a times. All right, so let's go ahead and start calculating this. 11 plus or minus. You can do this in the calculator. That is 121. If you're doing that in the calculator, make sure you use the parentheses. Parentheses are really important. They still remain important. This is going to be plus 48. Okay, it's negative 4 times 3 times negative 4. And then it's all over 6. So it's 11 plus or minus the square root of 169 all over 6. Okay, we're still not done yet. The square root of 169, you can use your calculator, is 13 all over 6. You have to go through and calculate these two values. So here's how you get one of them. You do 11 plus 13 over 6, and the other one is coming from 11 minus 13 all over 6. So you have to do this numerator and then divide it by 6, and then you have to do the numerator and divide it by 6. So this is 24 over 6, which is 4, and this is negative 2 over 6, which is negative 1/3. So 4, negative 1/3. I'm going to pop this in the calculator real quick. Yeah, verify graphically. So I'm going to go back to that equation and put it in the calculator. This is going to take a second. Okay, so let's see. So there it is in the y equals screen. Graph it. So remember, the solutions are where it crosses the x-axis. So just look. Here we go. It crosses there. That was 4. That was one of our solutions. And negative 1/3 is here just slightly to the left of 0, between 0 and negative 1. Okay, so let's move on. So one side equal to 0 first. Quadratic formula, or decide what A, B, and C are. A is 1, B is 3, C is negative 9. Okay, so x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So x equals the opposite of b, so negative 3, plus or minus b is just 3, minus 4 times 1 times negative 9, all over 2a, so 2 times 1. That's a times sign, y'all. Okay, negative 3. This is 9, and you can be doing this all on your calculator. 9 plus 36. This is all over 2. So it's negative 3 plus or minus root 45 all over 2. Okay, so here we go, you guys. So let's see. Find the exact solution and the approximate solution to 2 decimal places. Look at the notes or the instructions. When necessary, write your answer in reduced radical form. So this is why we went through all of this radical work before then. So you have to write this in simplified radical. So remember, root 45, biggest perfect square. So root 9, root 5. So this is negative 3 plus or minus. This will become 3 root 5 over 2. Okay, so that's your simplified radical. They want approximate solutions to 2 decimal places. So one of the values you're going to look at is this, and the other one is this. So we're going to put these in the calculator and round them to 2 places. I'm just going to quickly tell you, these are exact values. And these will be rounded, so they're not exact values. So if it says you want the exact value, this one says it wants the exact value and the approximate solution. So this would be exact values and these would be approximated. And the reason why they're approximated is because we're going to round. So when you go to use the calculator, do the stackable fraction. You're going to have to give yourself a few minutes to do this. Okay, so there's that one. Okay, that's the top one. 2 decimal places, so 1.85. And then you can go up in that and make it a minus. Negative 4.85. These are the approximate values, okay, because they're rounded. But they basically are, if you calculate these, this is what you'll get, the rounded values. Let's look at the calculator really quickly. Okay, so there's your quadratic. So let's see. So here's a solution that's not exactly at 2, but between 1 and 2. So there's that guy, okay? And then go back here. So between negative 4 and negative 5, but not exactly at negative 5. So there's that guy. I'll be back with more, everybody.